In this video, we're going to talk about the mathematical relationship between U and F. Mathematical relation between U and F. So to do this, we will take an example of Earth. So we have seen that if you have an object here of mass m, then your U is given by minus gmm by r. Your du by dr is plus gmm by r squared. So which is nothing but your force, gravitation force, but it's minus of the gravitation force, because your gravitation force is in this direction, your Fg, right? And your gmm by r squared is positive, so by our convention, so that's in this direction. So that's why you introduce a minus sign. So your Fg is equal to minus du by dr. So that's your force. In general, this is applicable for any conservative field. You can say F is minus du by dr, and this minus sign indicates that your force is in opposite direction of increasing U, and this is very critical to remember. So this is the first relationship that we need to remember. This is true for any conservative force. And the second relationship is just putting in mathematical equation what we have seen before. We have seen that the potential at a point R is the work done by field in moving that object from I to infinity, or you can say R to infinity, right? So in this case, if you have Earth, and if you have a ball at the radius r on the center of the Earth, your U at that distance r is the work done in moving this ball by the field from r to infinity. So that's equal to, mathematically you can write it as integral r to infinity f dot dr. So, or in a very general terms, you can write from r to the reference, zero reference. It can be for any conservative force, dot dr. So that's your U of r is equal to. So this is the second important concept that needs to be remembered. The third corollary is, so this is the second in the list. The third thing that we need to remember is when we say the field is doing a work, the work done by field from R to infinity. So we say the work done by field in moving from R to infinity is equal to minus work done by field from infinity to R. Now that's equal to work done by, let's say, external force or by me from infinity to r. Now, why this minus sign goes away is, let's say, for example, in case of gravity, as I'm moving from infinity to r, the gravitation force is going to be an attractive force, and I'm going to be applying a force in the opposite direction, right? So that's why if I had to say the work done by external force or by me, then it'll be opposite sign of work done by the field. So we can see that work done by the field in moving from r to infinity is equal to work done by me from moving infinity to r. Now, why this is important idea? It's an important idea because when you talk about a potential energy between two objects, let's say this is of mass m and this is of mass m, right, and this is at a distance r, right, we can say that u of r, when I say u of r, this is of the system, potential energy of the m and m system, that's equal to minus gmm by r, and this quantity is nothing but the work done by me to assemble the configuration against the field. Right? This is the work done, yeah, because this is nothing but this, which is same as this, right? So the way we envision is we take m from infinity to here, and there's no work that we did against the field, zero work from infinity to the point P, right? And then we take m and bring it from infinity. This m is, we bring it from infinity to this point r, and the work done is equal to minus gmm by r. So we can say that the potential energy of mm system is work done in assembling the system, right? And another way to, and this is not just for two objects. So if, let's say, for example, you have bodies 1, 2 and 3, so the work done in assembling is equal to u21 plus u31. So you're bringing 2 and 3 from infinity to their respective positions, and when you're bringing 3, then you need to consider you're bringing 3 against the field of 2 as well, right? So you're bringing first 1, and then you bring 2 against the field of 1, and then you bring 3 against the field of 1 and 2, right? So this is the work done in assembling the configuration, right? And if you want to move from this configuration to, if you want to change this to this configuration, right, to a new configuration, then so this is the initial potential energy, so this is your ui. Then you need to find what is your uf. That will be u21 plus u same 31 plus u32, and your work done is equal to uf minus ui. This is the same idea that we use when we find what is the energy required to lift a satellite from one orbit to another, right? So you have a satellite and you want to move it from one orbit to another. So what you do is from 1 to 2, and this is your Earth. So what you do is you first find out what is your u1, and then you find out what is your u2, and w will be u2 minus u1.